Okay, looking at this parabola, is it going up, down, right, or left?
It is going right.
Is it?
Left.
Is it?
Yes. No, it's going right.
How do you know if it's going up, down, right, or left? How do you know if it's going
square on the y?
The y is squared, so it's going left or right. It's negative, so it's going left. The negative 20 tells you it's going left. All right. The vertex is... Very good. Make sure you're taking the x part from the x and the y part from the y. Then to find the other stuff, we have to find the p-value. So negative 20 equals 4p, so p equals negative 5. Which means, since I'm opening to the left, you're going to move left 5 units to find my focal point. So if I'm at 1 and I move left 5, I'm at negative 4 for the x. If I'm at the point 1, negative 2, and I move right to find my directrix, where is my directrix? That x equals, add 5 to this guy, 6. You can also just kind of sketch it. They're going to ask you to sketch it anyway, so 1, 2, 3, 4, 5, there's my directrix. 1, 2, 3, 4, 5, there's my focal point. Remember, the vertex is always right in between the directrix and the focal point. Focal width. Right in plain sight, what is it? It's just 20. Remember, it's positive always because it's a distance. So to help me with graphing, at my focal point, I have to span 20. So I'm going to go up 10, and I'm going to go down 10. Go off the graph a little bit here, that's okay. And then you can at those 2 points with your vertex. That's your graph.
What is the point of the directrix if nothing?
It doesn't really affect how you're going to graph. But in reality, it affects how wide the parabola is. Because every point on this parabola, if I were to draw to the directrix and draw to the focal point, that should be the same distance. So it kind of, if you're graphing with like a computer or whatever, it would kind of pull it the same. Right? Okay, so we remember how to do that from yesterday. Who wasn't here yesterday? Everyone was here? Good. Okay, find the standard form of an equation with the parabola vertex 7, 2 at a focal point of 7, 6. So it's always good to maybe just kind of jot things down. I have a vertex at 7, 2, and my focus is above that at 7, 6. You can draw the whole graph, whatever you want to do, but this is what we need. So am I opening up, down, right, or left? Up, because the focal point is above the vertex. So if I'm opening up, that means what's squared, x or y? X. We already have our vertex, so I can put that in. Remember, x minus the x part, y minus the y part. And all I need to find is that 4p value. Is it going to be positive or negative? Since I'm opening up, it's going to be positive. And what's p? How far apart are these guys? 4 units, right? The 6 and the 2. So 4 times 4 is 16. Okay, so that's yesterday. You should be able to do all of that. Today, we're going to do ellipses. So ellipses, I'm going to show you real quick over to the side. So the focal points guide how wide, narrow your ellipse is. So the further apart that your focal points are, the more narrow it gets. The closer they get, the more round it gets. And if your focal points get so close that they end up being 1, you have it's a really, really round, circle, right? All right, so this is our equation for our ellipse. Now, technically, you could write down 2 equations, but why? There's no sense memorizing 2. That's the equation. Understand, though, your a squared and your b squared can switch. Okay? A squared and b squared can switch. So the HK is the center of the ellipse, just like it was your vertex. Goes in opposite. If I'm looking at this one, I'm just going to look at the left one here, the horizontal one. It's longer horizontally. If you go from the center of this ellipse all the way to the end point, we call that A. A is the longest length. Okay? If you go from the center and you go to the short side of your ellipse, that's B. That's the shorter than A, always shorter than A. And then the C value is the distance from the center to the focal points. You have three letters, A, B, and C. A is from the center to the long, your vertice. B is from the center to the short side. And C is the center to the focal points. Now, you guys see a right triangle? Okay. This A value that we have from the center to the long piece is actually the same length as the hypotenuse of this right triangle. It always works out that way. It's a cool thing. So in this triangle, this side's B, this side's C. The longest side is A. So if I'm going to do the Pythagorean theorem, it's not A squared plus B squared equals C squared. It's now B squared plus C squared equals A squared. A is the longest side between my C and my B. A is bigger. B and C, there's no rules for that one. Okay? One could be bigger than the other one. But A is the biggest. So if I'm looking at my equation, your A squared is always going to be bigger than your B squared. If A squared, if the bigger number is under your X, you have a horizontal ellipse. It's longer horizontally. If the A squared, the bigger number is under the Y, it's longer vertically. But there's no sense in you guys memorizing this equation. It's the same thing, isn't it? Except we move the A squared over here. Why write down two equations? Just understand that A squared can go from left to right. Okay? You can switch around. All right. We call the long axis the major axis, and the short one would be the minor. Right? Longest to major, shortest to minor. Okay? Let's see what we can get into. Let's try some. All right, here's our equation. What number represents A squared? 81. A squared always is the biggest. Okay? So we know this ellipse is longer left to right because it's under the X. Okay? So if 81 is A squared, what is A? 9. If 36 is B squared, B is 6. Those are our distances that we're going to travel from the center. So under the X, I'm going left to right, 9. And under the Y, you're going to go up and down, 6. What's my center? Was anything added or subtracted to my variables? No, so our center is just 0, 0. Right? So if there's nothing there, it's 0, 0. I'm going to move right 9. So the A and the B are like radiuses. You have a horizontal radius, and you have a vertical radius. And that's your ellipse. It's real easy to draw. That for the ellipse, yeah. That's how you have to draw them. They're very easy. Now, there's going to be questions they ask. For instance, how long is the major axis? 18, because I went left 9 and I went right 9, right? So the major is the longer one. The minor axis is how long? 12. So think of those as diameters, and your A and B are the radiuses, right? I can find focal points, or foci as they're called. Focal points have to go along the major. So if it's longer horizontally, we're going to do focal points along the major. For our focal points, we said that A squared equals B squared plus C squared. My a squared for my equation is 81. My b squared is 36. I subtract and I get 45. What's the square root of 45? Broken down into a nice, pretty, reduced radical. 3 square roots of 5. So that's my distance from my center to the focal points. So I'm going right to left. So here's my center. I go right. So I'm going to add 3 square roots of 5 to 0. So I'm at 3 square roots of 5. My y is still 0. I'm going left. 3 square roots of 0. So those are my focal points. Right? You don't need the focal points to graph the ellipse. You can estimate them. Square root of 5 is 1.7. 3 times 1.7. You're looking at 6 point something, right? 1, 2, 3, 4, 5, 6 point something. Back 1, 2, 3, 4, 5, 6 point something. Okay? Yes, ma'am?
Will the ellipse always start in the order?
No, it will not. Let's look at another example. You got those written down? What is the center here? 5, 0. Ha. What is my A value? A equals 8 and B equals 4. So which way am I going to go 8? Right and left, right? Horizontally? So how long is my major axis? And how long is my major axis? Or minor axis? 8. Okay. So we're going to find the vertices. The vertices are the endpoints of the major axis. So this is how I'm going to do it. My center is 5, 0. My major axis is going left to right? Yes? Nope. The bigger number's under the X, so that's why I know it's going left to right. So I'm going to take this and I'm going to add 8. Which one do I add to if I'm going right and left? The X or the Y? X. So 5 plus 8 is 13. That's one endpoint. I'm going to subtract 8. So 5 minus 8 is negative 3, 0. This is my other endpoint. So you're just moving back left to right. So that means you're affecting your X. You can always graph it. You can see that too. 1, 2, 3, 4, 5, 6, 7, 8 puts me at 13, 0. And negative 3, 0. Focal points. Oh, how many am I going to go up and down? 4? Our B value. So that's my ellipse. My focal points are somewhere along this major axis. Okay, so A squared equals B squared plus C squared. So my A squared is 64 equals 16 plus C squared. C squared equals 48. Break that down. What do you get?
Oh.
4 square roots of 3. That's your C value. So to find the focal points, again, you're sitting here at 5, 0. I'm going to add 4 square roots of 3. So just write it that way. 5 plus 4 square roots of 3. The y didn't change. It's still 0. On the other side, we're going to subtract 4 square roots of 3. So again, you're just going to show that. Those would be exact values instead of putting them as decimals. Okay? You're just changing the x values. Okay? Because you're going right to left. Make sense? There's little pieces, lots of little pieces.
Yeah.
My commercial. Here we go. See if you can do this. Figure out your center. Figure out your A, your B. What's the major axis length? What's the minor axis length? And figure out our C value. We can figure out our vertices and our focal points. Okay, did we get the center of negative 2, 4?
Yeah.
We get A is 5 and B is 2. So major is 10 and minor is 4. So the A squared is under the Y, so we're going to be going up and down to find my vertices. So my center is at negative 2, 4. I'm going to add 5 to the Y because I'm going up. I'm going to subtract 5 from the Y because I'm going down. So there's your vertices, negative 2, 9 and negative 2, negative 1. Focal point, your C value is the square root of 21. Same thing. I'm going to add and subtract that to my Y. That makes sense? Did we get all of it? Maybe the focal points got stuck? The center is always in between the focal points, or in between the vertices, or in between the minor axes and points. It's always the midpoint. Okay? Any questions? Let's go the other way. Let's get some little hints and write an equation. So, find the equation of an ellipse with the focal points, or the foci, of 0, negative 3, and 0, 3. So what can you figure out? They're giving you two focal points.
The center is 0.
Yeah, the center's got to be smack dab in between, right? Good. What else can you figure out?
C.
The C value is what?
3.
The C value is 3. Good. One more thing you can figure out. C. Yep, I'm talking about just that stuff I highlighted. What else can you tell? You've got the center, you've got the C value. Since the focal points are going up and down, the major axis is going to be under the Y, right? The A squared is going to be under the Y because the focal points go along the major. Since the focal points are changing Y values, that means the A squared is going to be under Y. Okay, so you can say my A squared is under my Y squared. So those are the three things I know, just from that little bit. Then they tell you the minor axis has a length of 4. What does that tell you? B equals what? 2. So in order to write the equation, I need an A and a B and a center. So I've got my B and I've got a C. So A squared equals B squared plus C squared. So A squared, B squared is 4, and C squared we said was 9. So my A squared is 13. I only need A squared for the equation. So I can write my equation now. So the equation is x minus 0 is just x squared plus y minus 0 is y squared. Under y squared I have my A squared, which is 13. And under x, I have my B squared, which is 4. And you're done. And you need to figure out your center. They're going to give you something to be able to figure out your A, your B, or your C, 2 out of the 3. Right? You good? Not going to worry about sketching it. Let's go. Try this. What do I get from the major axis endpoints? Those are the same thing as vertices. What can I get from that blue? A equals 7?
No, A equals 1.
Okay. How do you know your A? Okay, so A equals 5, and the A squared equals 25. Yes. Okay. Good. The center has got to be the midpoint between those 2 points, so we're going to add the x's. 6 divided by 2 is 3, and the y's are going to be the same. So far, so good. What else can I tell? Yep, x is going to have the a squared under it, right? So all of that from one little bit. And then again, we said the minor axis has length of 8, so my b equals 4. Can we write our equation? Lily?
I choose the 3.
So negative 2 plus 8 divided by 2. So that's the midpoint formula. Remember back in pre-algebra when they taught you that and you're like, when are we ever going to use that? Now, this is it, midpoint formula. It's important.
Can't you also just go from the endpoint and add 5?
If you figured out your A value first, then you can start at one point and drop down. Okay? All right. So we are ready to write our equation. It's going to be x minus x part of my center plus y minus the y part of my center. Remember, those go in opposites. A squared, we said, is under x, so my a squared is 25. The b squared is 16, and you're done. Didn't have to find c at all. Yes, ma'am?
Can you tell that your A was under your X because like your X's are changing?
Yep, your x's are changing in your major axis. Okay, whatever's changing in the major axis is how your ellipse is going to be going. Your major part, long part. All right? All right. So, let's try one more real quick. Think we can just skip this one?
Yeah.
You think?
Yeah.
I'm just going to do it real quick. I got other people watching. I mean, there may be 3 people that watch this video. You never know. Okay, major axis. Let's do it together. What's our center? 0 plus 6 divided by 2.
3.
Okay, major axis. What's our A value? From 3 to 6 is 3. And we are going this way, right? So x squared is over the a squared. Foci. You gave me the foci. So what my center is, again, is 3, negative 4. So what's my C value? C equals 2. X minus 3 squared plus y minus plus a 4 squared equals a squared goes on the bottom of the x. And my a squared equals b squared plus c squared. So b squared equals 5. Remember, b squared and a squared are what's in the equation. Quick enough. All right. So, writing in standard form. We're going to be completing the square like we did with the parabola. A little different because you have an x squared and a y squared. So the first thing we are going to do is we're going to get the x's kind of grouped together. So you have an x squared term and a regular x term, and then get your y squared term and your regular y term, and then you're going to throw the other number on the other side. Okay, so you're grouping your x's together and your y's together, other number on the other side. So, just like with the parabola, you are going to factor out these coefficients that are with my squares. So I have to factor out the 9. And you're going to figure out what am I going to add to make it a perfect square trinomial. And then I have to factor out the 4 over here with the y's. And again, I'm going to add something to make a perfect square trinomial. And you still have to add something to the other side as well. 2 times. And then what do we add? So remember, it's half the middle guy squared. So half of 2 is 1, squared is 1. But what did I actually add to that side? 9. In the second set of parentheses, here you have 2, same thing. Half of 2 is 1, squared is 1. That's just a coincidence that those both have to be a 1. And then you're going to add 4 to the other side. So you're just completing the square twice. 2 different little spots. And then you're going to write it in binomial factored form. So it's going to be x minus 1 squared plus 4 times y plus 1 squared equals 36. So I can see what my center is, but we're not quite in standard form. Standard form, the right side has to equal a 1. So we're going to go through here and divide everything by 36. These don't have to divide nice and pretty like they are, but they do in this case. If they don't divide pretty, guys, you just might have a fraction on the bottom. Okay. And then you can state all the stuff about the ellipse. Okay, the center is 1, negative 1. Is this a horizontal or vertical ellipse? Vertical, right? Because the a squared is bigger, 9. It's bigger than the y. And you can find the focal points and all that fun stuff. All right. Last example. One more. Not on this. Circles. So this is the circle formula. So if I wrote this as an ellipse, you'd have an r squared under both of those. Because your a and your b would be the same. We would call it the radius of the circle. But since it's a circle, we don't equal the right side 1. We leave it as an r squared. So they give us a center. They do not give us the radius. But they give us another point. So if I put this other point in for my x and my y, all this stuff on the right or the left side is going to go together to give me the radius. So negative 2 minus 3 is negative 5. Squared is 25. 3 plus 5 is 8. Squared is 64. So my radius squared is 69. So I would just go back up here. That's not 79. 89, good Lord. 89. So I just go back up there and say, that's my final equation. Does that make sense? It's not real hard to do the circle formula. You need to know the circle formula, though. Have it memorized. Okay? That is ellipses. So,